In chemistry, we use a special type of rounding called significant figures. Since chemistry uses measurements we read from instruments, significant figures allow us to be more precise and accurate. You may be thinking, what is a significant figure? No, it's not that. A significant figure is a digit in a number that defines its significance. So, for instance, in the number 100, the significance is in the 1 right here. Why? Because in problems without decimals, the first number that is not a 0 defines the significance. Now, if that number was 1100, then there would be two numbers of significance. If the number has a decimal such as 0.23100, then the number has 5. It includes the decimals that come after whole numbers that are to the right of the decimal. If the number is 7.203, then the number has 4 significant figures because we count both sides of the decimal. An easy way to remember this is by using the oceans. When you look at the number in question, you must determine if it has a decimal point or not. If it has a decimal, you should think of P for present, or Pacific Ocean, which is to the left. If the number does not have a decimal place, you should think of A for absent, or Atlantic Ocean, which is to the right. Now say you wanted to subtract 1.3 from 100 using significance. Using basic math, you would get 98.7, but we want to round using significant figures. Would the rounded answer now be 98? Nope. Actually, the answer is 100. Why? Because in the problem, 100 is the least accurate number, and we lean towards those when looking for significance. And as we have learned earlier, 100 has a significance in the 1, making it so that we round it to the hundredth place, making out the answer of 100.
Let's try this with another addition problem.
If you had 4,302 grams of substance and you wanted to add 0.837 grams to it, what would the answer be? Would it be 4,302.837 grams? Nope, it's actually 4,303 grams.
How's it 4,303?
Simply because 4,302 in the problem is the least accurate number, and it has 4 significant figures, making it so that the answer must be rounded to 4 significant figures, giving us 4,303. Multiplying and dividing with significant figures is only slightly different than adding and subtracting. Take for example 10.2 grams divided by 0.4 grams. Basic math yields the answer 25.5, but because we are having to deal with significant figures, 25.5 is wrong. The decimal being 5 and the fact that we have to round to the 10th place, the answer is 30. Now let's try a multiplication problem. What would 5.40 centimeters times 11 centimeters times 87.300 centimeters be? The answer is 5,200 because 11 is the least accurate number, so the answer can only have 2 significant figures present. Also, don't forget that when multiplying centimeters 3 times, you must include centimeters cubed as your unit. Let's review some practice problems and answer them in significant figures. What is 9.44 meters minus 2.1 meters? The answer is 7.3 meters. What is 61.2 milliliters plus 9.35 milliliters plus 8.6 milliliters? The answer is 79.2 milliliters. What is 8.3 grams times 1.22 grams? The answer is 10 grams squared. And finally, what is 8,432 milliliters divided by 12.5 milliliters? The answer is 675 milliliters.
If you still think these are hard, don't worry, it takes a lot of practice.
Alright, go ahead.
If you think these problems are hard...
Okay, go ahead and start spinning around. Now talk.
If you still think these are...
And go.
If you still think these are hard... Why can't I do it?
Talk.
And don't worry, even if you don't immediately understand... I can do it.